All right, welcome back. Today we are going to start in on section 2.4, literal equations and formulas. We'll go through about a third of the notes, maybe a little bit more today. I would encourage you as you are going through these to hit the pause button after each example. That way you can write down what I'm talking about, and then when you're ready to go, hit play again. You got plenty of time this hour to watch these notes and start in on the homework. So a literal equation is an equation with more than one variable. For example, formulas for circumference or the perimeter of an object, area, temperature conversions, those are all examples of literal equations, and that is going to be the focus in our second half of this section. So here's just an example of a couple here of literal equations. So you can see the first one is circumference, which is 2 pi times the radius. So that's how we find the distance around a circle. The second one is perimeter, and perimeter is 2 times the length plus 2 times the width. And in this case, we're talking about a rectangular or square shape. You have 2 lengths, 2 widths. If you add them up, you have two of the lengths, 2 of the widths. So that's why we multiply by 2. And that will give you the total distance or perimeter around a rectangular object. So again, that's the perimeter, 2 times the length plus 2 times the width. Circumference is just a big word for basically saying the perimeter of a circle. So again, the distance around a circle is 2 times pi times the radius of the circle. The area of a triangle is 1/2 the base times height. So if we know the base and we know the height, we can multiply that by 1/2 and find the area of a triangle. Again, we'll be working with these formulas as we go. This one here, this is for temperature. So in this case, we're looking for Celsius. So we can take 5/9 times the Fahrenheit temperature minus 32. So much like the metric system, where most of the world's using centimeters, meters, and so forth, and we're using feet, inches, and yards and miles, most of the world uses Celsius for temperature. We use Fahrenheit. So we can convert them back and forth using this formula right here. So these are all examples of literal equations. Now, what we're going to be doing today is this piece here. We're going to be given a traditional equation with an x and y, and we are going to solve each equation for y. In other words, get it to y equals, and then we want to find the value of the equation given an x value. So there's going to be a couple pieces to this. So we're going to start off with this equation right here, this 2x plus y equals 5. We are going to get this to y equals. So just like we would move a number by adding or subtracting, same thing here with 2x. So we are going to subtract 2x to the other side, like so. So you've done this before. So we subtract 2x to get it over to the other side of the equal sign. And that will give us y equals 5 minus 2x. Or, if you prefer, we can put the x term first, which would be negative 2x plus 5. So that's your option. We can write it as 5 minus 2x, or we could write negative 2x plus 5. Really doesn't matter. It's your choice. Personally, I usually write the x term first, but again, either answer is correct. So we've done the first part now. We have solved this equation for y. We have y equals. Now we get to these two numbers right here. So what we're going to do is we're going to plug 0 in for x and see what y equals. Then we're going to plug negative 3 in for x and see again what y equals. So we'll start off with that first one. We'll plug 0 in. Negative 2 times 0 is 0, so 5 minus 0. So we know that y is 5. So again, I just plug 0 into this equation for x to solve for y. Now to finish this out, we're going to plug negative 3 in for x. So again, I plug negative 3 in here. So negative 2 times negative 3 will be plus 6. 5 plus 6 for 11. So So again, solve the equation for y, get it to y equals, and then we plug in 0 for x, and then we plug in -3 for x, and find out what our variable equals. And again, if you need extra time, just hit pause at any time, and then you can finish out this slide or whatever slide you're on. But hit pause as you need to write things down, and then you can continue on. All right, our next example, and what we have here, we are going to have two examples here. Again, we're going to solve each equation for y, and then we are going to find the value of y given these x values. So we're going to do the same thing we just did on the previous slide. Solve this equation right here for y. So to start, we are going to add 5x to both sides. And when I do that, I am going to get 3y equal to 5x minus 9. Again, I can't add these together because they're not like terms. I want to get to y equals, so I am going to divide by 3. And that will give me this equation right here, 5/3 x minus 3. Now at this point, I have everything I need to plug these values in. So I'm going to plug -4 in for x, and I'm going to plug 0 in for x. All right, so what you see below this orange line here, as we start, we're going to plug the two numbers in for our x value. So we're going to plug -4 in here for x and 0. So when I take -4 times 5/3, I'm going to get a decimal. That's fine. -6.6 repeating. I'm going to subtract 3 from that, so -9.6. When I plug 0 in, that's a little easier. Obviously, 5/3 times 0 is 0. 0 minus 3 is -3. So again, first step, solve the equation for y. Second step, plug these two numbers in for x to figure out what y equals. Again, before we move forward, if you need to, hit pause, finish this one up, and then we'll slide over here. All right, second example, very similar to what we did over here. We're going to solve for y again. So I am going to move the 3 over. Let me get this box out of the way. Basically what I did, I just put this side, 3 minus 2y, I put over here on the left and the 8x over here. That's fine. So I just flip-flopped them. -3 from the 8x, so that gets me right here. And then I divide by -2. So ultimately, when I solve for y, I get -4x plus 1.5. And now I can plug in my x values that you see right here. So that's what I'm going to do. I'm going to plug -2 in for x, and I'm going to plug 1 in for x. So when I plug -2 in, -4 times -2 is 8. 8 plus 1.5 will give me 9.5. When I plug 1 in for x, -4 times 1 will be -4, plus 1.5. Careful with this one now. This will be -2.5 because I got a negative plus a positive. So again, solve the equation for y. Once I get to y equals, plug these numbers in for x. So -2 here and 1 there to find out what y equals, and then you're good to go. Again, just a reminder, hit pause as you need to so you can write down everything as we go. And we have one more page in our notes for today. All right, the last page of the packet that we're going to do today is this example here. It's going to say write the equation so that y is a function of x. That is just a different way of saying solve for y. So we are doing the same thing that we did on the previous page. We're just going to take this equation and get it to y equals. Same thing right here. We're going to get it to y equals. If you look carefully at your note packet, you'll notice that these examples right here at the top of this page are the same as the ones on the bottom. So we don't have to do them twice. We'll just do this one, and that'll be it for today. So if I look at my first one here, I want to solve this for y. First thing I'm going to do, I want to get y equals, I want to move this 6 out of the way. And before I even do that, I'm going to put the -6 plus 7y on the left side and the 2x plus 8 over on the right side. Now, it's not necessary to do that, but since we're solving for y, I think it's easier to have it on the left side. So I just put this over here, this 2x plus 8 over on the other side. So notice we didn't change any of the values. We left the numbers as they were. So I'm going to add 6 here to 8. That'll give me 14. 7 times y, so I need to divide by 7. And that gives me my equation right here. And I will leave this, when you divide, leave this as a fraction, as 2/7. If it was 2 over 8 and you want to simplify to 0.25, that'd be fine, or 2 over 4 to 0.5. But since we have a fraction here, it doesn't reduce, just leave it as 2/7 x plus 2. All right, last example for the day. We're going to solve this one for y. So I got to get that 6x over to the other side. So I am going to subtract that from 20. These are not like terms, so you can't combine them. So I'm going to end up with negative 4y equal to negative 6 plus 20. My last step, I'm going to divide everything by negative 4. And this time we will be able to reduce this, and we'll go ahead and do that. So you can see we've got 3/2 x, or if you want to, you could change it to 1.5x. I don't advise that, just for the fact that we're going to eventually start graphing these, and it's easier to do slope when they're fractions. But negative 6 over negative 4 reduces to 3/2. Again, negative divided by negative is a positive. 20 divided by negative 4 for negative 5. So now I have solved both of these equations to get them in terms of y. So that's your notes for today. You should be all set now to complete your homework, which is 2-5 day 1. I will be back tomorrow. We'll go through the homework and then finish out our notes here. All right, thanks a lot.